Hi everyone. I'm super excited to be part of the session today, and I'm really happy to have Ceramic of DAO Global Hackathon. I'm really excited to see what hackers can build. I think in general, DAO space and DAO tooling space is such an interesting field right now. There is so much to do, so many new tools to build. So it's great to be part of this. I'm really thankful for Aragon for organizing this, and hopefully that hackers will have really great experience. So in this session, I just wanted to cover some of the fundamentals of Ceramic and ComposeDB, which is our new GraphQL interface that we released very recently on Ceramic. So I will have some theoretical bits and also some practical bits. So hopefully it will make it easier for developers, regardless of how experienced you are with Ceramic, to use it for your projects during this hackathon. So very quickly about myself, my name is Justina. I am working as a developer success lead at Ceramic. My main responsibility is to make sure that developers have all of the tools, education, and resources to build great applications on Ceramic. So if you have any feedback, requests, or just in general, any thoughts about Ceramic and ComposeDB as you work on your projects, I am the best person to share all of those details with, because then I can bring all of them and work with our core team to make sure that they are all addressed. So if you have any questions or just in general like to get in touch with me throughout the hackathon or after, there's my Twitter handle. You can also see my email, so feel free to reach out. Would be very happy to talk to anyone that is interested in decentralized data infrastructure or Ceramic specifically. Feel free to reach out. Very quick agenda for my workshop today. So I will do a quick intro to Ceramic and ComposeDB, some background and core concepts that I think are really useful to understand before you get started with your project. And then I will showcase some of the things of using ComposeDB in action. And at the end, I will share some resources that I think will be useful for any hacker in this hackathon to work on their projects and get some inspirations on what to build as well. So very quickly about our bounties. So our team wanted to incentivize hackers to build DAO tools using ComposeDB on Ceramic. So we don't have any specific requirements for what kind of tooling it has to be. We just want to see developers utilizing ComposeDB on Ceramic. That is our core requirement, that it has to be ComposeDB that is used in their projects. We want to see developers building tools that would make it easier for developers to build new DAOs, or that would accelerate the scaling and growth of existing DAOs. So anything from easier ways to manage proposals, share information, facilitate discussions, to tracking user contributions and members of the DAO, and like what kind of work they do, building their reputation systems and so on. These are the things that we would really like to see developers to create for this hackathon. There are some aspects in Ceramic and ComposeDB that I will cover in a little bit more detail later, like composability and data interoperability. And if hackers can utilize ComposeDB to really take advantage of those aspects, it would be really, really great. So we have some small bounties for this hackathon. We'll be rewarding 3 projects, and each project will get $500 each. We would also love to see developers combining Ceramic with other tools out there. So we would really like to see what kind of integrations you manage to build and so on. So yeah, those are the bounties. I really hope to see some really cool projects at the end of this hackathon. So now let's dive into ComposeDB on Ceramic. So ComposeDB on Ceramic, as I said, is a fairly new GraphQL interface that we built on top of Ceramic. And it is designed to bring data composability and interoperability to Web3 apps. We launched it just about a month ago, so there are quite a lot of things that we would like to improve, and this is perfect opportunity for developers to tell us what they would like to see in ComposeDB. But at the same time, right now, ComposeDB is feature complete, and it is designed to make it easier for developers to store data that users generate while interacting with applications that are built on top of Ceramic. Also, it is designed to make it easier to interact with that data, to make mutations, write queries, and to really build better user experiences when it comes to developing new decentralized applications. The best way of how I can describe what value ComposeDB and Ceramic brings to the users is through a small, simple example. And this example compares experiences of how how building applications in, for example, Web 2 is, and what kind of difference ComposeDB brings into the picture. So imagine that we are now in, let's say, Web 2 world, and we have a user, they sign up for a social app, let's say it's Twitter, and usually user journey looks like as follows. They sign up for their app, they have to provide some information about themselves, like their name, birthday, location, and other details. Then they set their site preferences, what kind of things they want to see, what kind of notifications they want to get, how the app should look like, and so on. And finally, they start building their social profile, what kind of people they want to follow, and so on. Then let's say a user decided to sign up for another app, same field, social app. Let's say they decided to use Instagram, for example, or maybe something like TikTok would be a better example. So they sign up for it, and it's the same process that they have to follow. Once again, they have to sign up, provide the same information, set the preferences, start building their social graph from scratch. And for every single new application that is out there that the user would like to use, this is the process that they have to follow. So in general, it's not great user experience because they have to repeat the same steps over and over again. And more importantly, they have to build their social graph for every single application, for every single platform from scratch. And also at the end of the day, different companies that own these applications, they also own the data and they store that on different centralized servers somewhere. So there is also this question about who should have the ownership of users' data. From developer perspective, this is a very simplified view as well of how things look like. But as you build an application for every single app and most of the time feature, you have to follow the same loop. So you build an experience where user interact with some kind of service. There are some APIs involved that pull data. They also store data somewhere on a server somewhere. And then depending on what kind of action the user wanted to perform while interacting with the application, they get some kind of specific view that is generated for them, and then the cycle continues. So the same thing here again. A lot of repeated work, and developers most of the time have to start from scratch. There is also this quite challenging cold start issue that developers have to deal with in Web 2, especially when it comes to building new apps, and they don't have a lot of users to start with, so they don't have a lot of data to work with, and the user experience that they can offer the users is quite limited and poor. So those are the things that we try to tackle with Ceramic and ComposeDB. And at the core of those improvements is this small little component called data model. With ComposeDB, we approach building applications from a developer perspective as sort of like building your app with using small building blocks, like Lego blocks, so that you put one block, then you put another, and so on. And each of those Lego blocks is a data model. A data model basically defines what a specific feature in your app looks like. So there are some details that you have to define for a data model, like some metadata like model name, description, and then you can define how the schema of that specific feature looks like. And that feature or a data model can be for anything that your app needs to operate. So for example, you can have a data model for user profile, you can have a data model for a comment, a post, follow, like literally any feature that your app will need, you will potentially have a specific data model for it. Using GraphQL, you can define how the schema of your model looks like. And then when you add new features to your app, you will define these schemas exactly the same way. Now, the beauty of all of this is that those models, they can also be shared on the network with other developers. So this is where data composability aspect comes in. So data models can be shared with other developers on the network. I will show you how we can access them as well. So if you are just getting started with your application, our recommended way of building your app is to actually look at currently existing data models. And this basically means that you don't have to define those, for example, most common data models from scratch yourself. For example, I can imagine that almost every single app will need some kind of feature like user profile. So instead of having to write it from scratch yourself, you can just pull what already exists and use that for your application and then build some custom models on top. Another really cool thing about these data models and being able to share them on the network is that if two applications, two completely different decentralized apps are using the same data models, then the data between those apps will be shared automatically as well. So this means that, for example, if this dApp and this dApp is using the same user profile model, the data of between those two applications will be automatically synced and shared. So this gives developers a little bit more open and public data to work with when they start building their applications. And from the user perspective, that means that they can, as I had in this slide, when they sign up for one app and then they sign up for the other app, they wouldn't have to, in this specific example, they wouldn't have to create their profile completely from scratch. They would simply bring their profile that is already created to a new app. Once they sign up, once they approve the app and authenticate the app using, let's say, their Ethereum wallet, their profile will be automatically populated for them. The same if, let's say, two different apps are using the same social graph model. For example, what kind of people you follow. So then the users, when they sign up for a new app that is using the same data models as other apps, they will bring their social graph to different apps as well. So they don't have to start completely from scratch every single time. Another thing that is important to mention here is that all of the data streams that users generate as they interact with applications built on Ceramic, they are tied to users' decentralized identifier, a DID, which means that only the user himself or herself, only they can write into the data streams, they can do mutations, so for example, update their profiles or follow and unfollow people and so on. So we just want to make sure that users in the end own their data and they can decide what's being done with their data and where the data is being used, and none of that data is being stored specifically on specific centralized database somewhere. So yeah, so this is where I was moving towards speaking about sovereign data. We want to make sure that users have as much ownership of a lot of different pieces of data as possible, and that really depends on what kind of applications are being built on Ceramic. But we believe that things like your profile, account links, social verifications, social infrastructure, credentials, cookies, any kind of metadata, your user-generated content and things like that, that they belong to you and that you are the sole owner of those data streams. So the easiest way to understand how this works with Ceramic, if you have your Ethereum wallet and you interact with applications that are built on Ceramic network, only you will be able to make changes to the data that you generated, create new data streams, and so on. Now, speaking about Ceramic and ComposeDB, just a quick overview of how all of the pieces work together. There are three main components. So at the very bottom, we have Ceramic nodes. Again, Ceramic is a decentralized network, so we encourage developers to run their own nodes when they build applications on Ceramic. This is to make it easier to scale the network. And also, especially at the very beginning, as you build your application, you can actually choose what kind of streams you want to be stored on your node. So for example, you can store data streams from other applications, especially if your application is using the same data models as other apps and so on. Yeah, so this is where the data that your app that you built runs on, this is where it will be stored. Then on top of that, we have ComposeDB, which is a GraphQL interface. This is what you can use to create those data models that I mentioned before. This is where you can perform indexing so that it's much easier and faster to access the data. And this is how you can interact with data much easier by writing quite simple GraphQL queries. I will show you a quick example of that as well a little bit later. And at the very top, we have those Lego pieces, data models that can be combined into composites. A composite is basically a collection of data models that can be used to basically define the GraphQL schema of your entire application. And as I mentioned previously, that everything is controlled by decentralized identifiers in terms of what kind of data will be stored there. Now, there aren't a very specific use case or one use case that we built Ceramic and ComposeDB for. This is really something that we would like developers to see as data infrastructure that they can use for any application out there. We do see some more popular applications so far. So some of them I've written down here. So we do see developers using ComposeDB for building apps that make it easier to manage decentralized identities like profiles, credentials, reputation systems. Then a very popular use case is applications around social networks. So making it easier for users to build their social graphs, write posts, likes, and stuff like that. Then DAO tooling is another very important piece. And again, that's the reason why we are partnering with Aragon for this hackathon, because we would like to see more of these kind of applications built. So tools that make it easier to manage proposals, tasks, contribution graphs, and to make sure that developers that are part of different organizations, that they can be recognized for the work that they do, and we would really love to see more tools that would allow developers to sort of build their reputation and bring that from one DAO to another with them, so that it wouldn't be siloed from different organizations, but something that would allow them to build their profile, their reputation that they could bring to any other organization that they join. And then we see a lot of traction from DeSci, for example, that are dealing with a lot of data and science graphs, so applications that are built around those kind of things. And also there are more applications that we see. We get a lot of interest from users building Web3 gaming applications and others. So yeah, there is really no limit for what kind of apps you can build. So for this hackathon as well, we'd really like to see some creative ideas and interesting approaches for DAOs and DAO tooling. Now I have a few more slides covering the core components of ComposeDB. Before I dive into that part, just a quick check if there are any questions that I have to address. I tried to pull my comments and I don't think that I can see it now. Oh, I can see it now. Okay, I don't see any questions right now, so I'll just keep going, but I will pause a little bit later once again. So okay, so I wanted to, as I said, I wanted to cover a few core components of ComposeDB. So terms that developers will have to understand as they build their applications. So the first one that I mentioned a few times already is how specific accounts of the users are managed. So everything, all of the data streams that users generate while interacting with applications built on Ceramic are tied to their decentralized identifier. So in Ceramic and ComposeDB right now, we have an option to use sign-in with Ethereum as your sign-in method. So basically, it means that if you have an Ethereum wallet, you will have a DID created for you, and you can manage all of the data streams, all of the data that is generated as you interact with your application through that. All of these DIDs, decentralized identifiers, they are used under the hood to authorize some specific operations, like, for example, when you write new data into the stream, or when you mutate existing data, for example, when you update your profile, and so on. All of that has to be checked and authorized, and only then those changes will be executed. Then the next very important component, I spoke about this quite a few times now, so I will not dive too much more here, but data models. As I said, those building blocks that you can use to build out your application. You will need data model for basically every single feature of your app. You can use those data models publicly with other developers for them to use. How many data models you will use for your app very heavily depends on your application. If it's a very, very basic, simple app, you can have just 2 data models, but if your application is bigger, you will probably deal with maybe 10 or more data models. You can also define relations between data models. So that means that you will be able to interact with data between those models. So for example, you will be write queries to access, let's say, what kind of posts people that you follow shared, and so on. So this allows a little bit more advanced user experience when you build your application. So you can really take advantage of that. So model catalog is the place where those data models can be shared. I will show an actual example of that in action. But basically, it's a right now very simple CLI command that you can run, and it's a very basic table that gives you a list of currently existing data models. You can see some details about them. What is the name of the model? What is the description of the model? You also get a model ID, and then using that ID, you can fetch the model on your own node and start using that for your application. So every time a developer builds new data model and they index it, I will show how that looks like as well. The model automatically becomes available on the model catalog, and it becomes available for other developers to use. Right now it's automatic is because we want to incentivize developers to share more and at the same time to use data model catalog a little bit more, so that more developers can take advantage of data composability aspect and data interoperability as well. Composites, I mentioned them before. They are building blocks used by developers. You can imagine and understand a composite as a collection of data models. So for example, when you build those Lego blocks, when you define the schemas for your separate features like profile, blog post, comment, and so on, you create a composite, which is basically a collection of all of these models. That makes it easier to manage your application, to build it, to deploy your application. You can always take things out from a composite, you can add new things, but it just speeds up the development of your application. We also have different networks that developers can use. We have mainnet, and this is what developers can use for running their application in production. So we recommend developers to run on the mainnet when they are ready to run their app in prod. If you are just getting started and you're building new application, we highly recommend developers to start with testnet. So for example, Plate testnet is our testing network. Sorry. And then we have Dev Unstable. And Dev Unstable is another testnet, but this is mostly used for testing and for small things that developers can just simply test out. So yeah, and there is more documentation that you can find if you want to see how you can run nodes by yourself. The main thing to remember about building on Ceramic is that, as I mentioned in previously, we do incentivize developers to run their own node if they build their app. Okay, let's dive into a more practical part. I will let my voice to rest a little bit as well in between. I just wanted to show you how we can interact with Ceramic, and I will cover two main things. So the first one is how they can use the CLI, and another one is how we can do all of the things programmatically. I will not be building anything from scratch today, but I will be using an actual example application that you can also use for your project, and something that hopefully make a few steps easier for you as well. So in terms of technical requirements, so I don't think that anyone is, I don't expect anyone to follow all of the steps today, but to build something using Ceramic, you will need just a few things. So you'll need code editor, a browser, you will need Node.js version 16 and NPM version 8. If you have those things installed on your environment when you start working on your project, you will be good to go, and you will be able to build your app quite easily. All right, so this is where I will start switching between my slides and a little bit of coding. So the first thing that I wanted to show you is where this example is. I just noticed that I didn't update my link here, which I will do. But basically we have, sorry, just moving the Zoom things. Yeah, so instead of Denver workshop, which is a little bit old repository, we have Aragon workshop. So one of the workspaces on Ceramic is Ceramic Studio. So this is where the this repository is. And this repository contains a very simple example of a very basic small application that is built using Ceramic and ComposeDB. I will show you how this app works in practice, but this is basically what I will be using here. I will make sure that this link to my slides also is available for developers so that you can get these links as well. Okay, so I have this repository already available on my machine. I cloned it already, so I'll just open it in my VS Code because that's my code editor of choice. And then I will do majority of things here. So as you can see, I have quite a few quite a few files. So the first thing that I will do is I will quickly install the dependencies. You can see the list of dependencies in the package.json file, but just quickly to walk you through, it's mostly Ceramic dependencies, like Ceramic CLI, which makes it easier to interact with Ceramic. And also we have quite a few ComposeDB dependencies, and then a few additional things that are necessary to run the app. So I will install everything with npm install. This should take just a few seconds. And while this is doing that, I will keep going and cover the steps around account management. So if you remember, I did mention that everything in Ceramic in general, all of the streams, they are tied to users' decentralized identifier. So to generate a decentralized identifier in the first place and for example, as you start building your application, you will have to provide your decentralized identifier in your node configuration, so that when you are testing your app, when you are running some mutations manually, you will want to make sure that those are authorized and approved. So this can be done by running just a few very simple commands. So I will just run them and show you how that works in practice. And we have everything installed here. So if I run ComposeDB did generate private key, I should get a brand new private key generated for me. This private key will be necessary to authorize any kind of interactions that will be required by my admin API. So you can see after I run this command, I have a private key generated for me. And then using that private key, I can get a decentralized identifier as well. Just to make everything quicker, I will copy these commands. And I will just provide my actual key. And this, as you can see now, generated an actual did key. So now I should be able to use this did and the private key to authorize necessary, for example, mutations and any kind of important updates to my data streams. Now, how this looks like from the actual app perspective. So since I already have this small app built out, I can show you an example how the node configuration file looks like. If you get started from scratch, you will have to generate the did and the private key, just like I showed you, and provide them in your node configuration file that will be automatically generated for you as you launch your node. So I have one of those files ready for me here. And this is where you can basically configure any kind of necessary configurations for your node. The most important thing right now is the actual admin did. So this section right here, as you can see, I have that did key provided here. And also I have admin seed, which is my private key. By the way, this is the worst way to handle private keys. You should never store them in text files like this, but this is just for a simple and quick demonstration. You should store them somewhere safe and make sure that you don't lose them. Or if you start building, you can set them as environmental variables, but you should never expose them like that. This is just a small demonstration use case here. So now, since I have this key and I have my did that is configured and added as an admin key, I can interact with my app. I can write mutations, create new streams, and things like that. So next thing that I wanted to show you is some quick interactions with ComposeDB CLI. So one thing that I mentioned before is that you can technically get a list of currently existing data models. So I wanted to show you how that would look like. So ComposeDB has a command called model list. And if you configure the network, for example, you can specify that you want to see models that are currently available on testnet Clay. You can define that as a flag as well. If you don't specify this, you should access models that are currently available on the mainnet. Maybe I will actually show that first. And I will provide a flag table, because then it should give the results in a bit nicer table view. So once I run this, as I said, this is very basic and very simple interface as of now. We will be spending more time looking into how we can improve this platform. But basically, you get a list of currently available data models that you can pull and use for your application. So you get details about the model, like what's the model name, what's the description, what's the ID, and then using that ID, you can actually fetch the model on your local node and use that. I will quickly maybe show how that works as well, so that you can see how that works in practice. So to pull an existing model, you have to use CLI command ComposeDB composite from the model, and then provide that model ID that you want to pull. So I will do that to show a quick example. And also now at this point, I will need a Ceramic node running. So I will start my Ceramic node with Ceramic daemon. And I will provide configuration file, so that, because this is where my node configuration lives inside of this ComposeDB config.json file. So I will provide that. Config.json. And that should start the Ceramic node. I can see what configuration my Ceramic node is using. This is the same one that I have in this file above. So this is correct. And now it should start the node in just a few seconds. And once it's up, I should be able to interact with it, for example, pull the models, deploy them, and start interacting with them. So I will do that in a second once the node is up and running. So as you can see right now, it's still saying that it's connecting to the Ceramic network. I'm just checking that I didn't forget anything. That's interesting. We had some issues with our testnet, and I am wondering if that's exactly what is happening right now today during the workshop. Let me try something else. I will try running the app, actually, the entire app instead of the CLI, and see if it makes any difference. Hopefully this is more promising. If not, if this doesn't work for now, and I will have to go back to my team to see what's happening, I will still walk you through the main components so that you understand what's happening. But it would be a shame if I cannot show you an actual demo right now. Well, let's see. While this is loading, actually, maybe I'll, for the interest of time, I will start doing that, actually. So yeah, so if you want to pull the model, as I said, you can run a CLI command, define what kind of model you want to pull, and then you will be able to start using for your application. Now, what happens if you want to start writing new models? So I have a few examples of that in my app. So if you go to Composites directory, I have a few models that are completely new that are written here, and I just wanted to show you how the GraphQL representation of those models looks like. So I have basic profile model here, and it's a very basic profile that allows Ceramic to store information about the user, like their name, username, description, their gender, emoji, and things like that. And this is how you would define a GraphQL schema of your feature, like basic profile. So in GraphQL, you have to provide just a few small details, like you define the name of your model, you provide the directive create model, which means that you are creating new model from scratch. Then you have to provide account relation type, and there are two account relation types. One of them is single, which means that one account, so for example, one Ethereum wallet, can have only one basic user profile associated with it. In other situations, for example, if you are building Web3 social app and you want to add posts model, it's likely that users should be able to create more than one post. So then you will have account relation list, which will mean that one user can create more than one post. In this case, we have relation single, which means, again, that user can have only one profile associated with them. That profile obviously can be updated by writing mutations, but in general, it's just one profile that exists at a time for the user. Then you can provide the description, which defines what the model is about. This description is what you will see in the model catalog and what other developers will see on the model catalog. So you have to try and make sure that those descriptions are short, but also informative, so that it's easier for other developers to understand what the model is about. And then you can define the fields for your data model. So for example, we have name, username, description, gender, emoji, and you can use GraphQL scalars as well to define and directives to define what kind of type the specific field is. In our case, all of them are strings, and you can also define what kind of limitations or requirements a specific field has to meet. So for example, here we only have what is the length of a field name, that it has to be between 3 and 100 characters. In other situations, you might want to create relations between the models, as I mentioned. So I have an example for that as well. So we have another model called post.GraphQL. So here we are defining a relation between posts model. So whatever, what kind of, imagine in a, let's say, Twitter, for example, that users can create posts. And we want to make sure that posts that users are creating, that they are linked to their profile. So this is how we can define a model with relations. At first, you will have to load an existing model. So that basic profile that is defined here, once it's deployed and indexed on your node, I will try to make sure that I can show how that works in action. But basically, once you run your app, it should automatically index the models that you have defined. And then this specific model will have that model ID attached to it, so that other developers can use your model, but also you can use your model in a much easier way when defining other models as well. So this is what's happening here. At first, we are loading the basic profile model using the model ID. And then we are defining a new model called posts. As you can see, once again, we have a directive create model. This model has a different directive load model, which means that we are loading an existing one. And here we are creating a new one. And then the same thing, we define the account relation. Here we have account relation list, description, we have fields. And the main thing that is different here is that we have these document reference and relation document directives. And they are important here because using them, we can define the relation between these two models. So by adding document reference, we are defining what other model we are creating the relation to. So for example, we have this post model and we are creating a relation to basic profile model. So this is how we will able to define that relation between the two models so that you can then link the data between the two. And also we define which property will be used to create that relation. In this case, it will be profile ID. We will have a profile ID that is here, and we will be attaching that profile ID to posts that are created by the user. And then by having all of this set up, we will be able to write queries to pull data. So for example, you will be able to see what kind of posts were created by a specific user at a specific time, and so on. You can also define opposite relations. So for example, here we have relation between basic posts and profile. If you want to be able to query data the other way around, you can also define relations between basic profile and posts, and so on. So yeah, I think I see a little bit more promising things in my output right now. I might be able to show an actual app, how that looks like. But before that happens, I will also want to show one more thing, which is what happens as the user interact with their application. So I mentioned all of those mutations, writing new data, pulling data, and so on. So as you build your app, you will obviously create a front end. This specific example has a very small and basic front end available as well. But you can basically define what happens when users interact with specific buttons or specific fields on your app. So let me see if I can find a good one. Yeah, maybe this one would be best. So here we have an example of what happens when user creates a new post using the front end of the application. In the backend, all of these GraphQL queries that I mentioned before are being used. So we get the user profile first of who created a post. And when the creation of new post is happening, you can see that we are running mutation that basically creates a new post that the user created, and it writes it in the database that is then available for on the app, for example. So as you create your app, this is what kind of things you will have to mainly do. You will have to create the models, define them, and then as you build your app and think about what has to happen when users interact with the front end, you will have to include these either reading the data or writing mutations and updating existing data, and so on. Let me see. I wanted to try and run and open the app to show you how. This is just a very quick view of the app. Again, it's very basic. This is just for developers to get a taste of like how things look like, how they work. So on this app, since I have that basic profile model, I'm able to create a simple profile. So I will very quickly do that. Hackathon, my gender and emoji. So I will try updating my profile. If my node is running correctly, which I hope it does now, it should write the data in. Also, since I interacted with this app a little bit earlier, I didn't have to sign in with my Ethereum wallet. But if you are starting this app completely from scratch in your own time, then you will also get the pop-ups to sign a few interactions there. Come on. Let's see what's happening. Yeah, we have been having, as I mentioned before, yesterday, some issues with some things with our testnet, and I really thought they were fixed now, but I think this is still happening here, which is a shame because I really wanted to show some of the things still. Yeah, so basically, not to use too much time. So you would be able to create your profile. You would be able to create posts. For example, I don't know if that will work. And click share. And then once they are written, they should be available for you to interact with. I don't know if this will work. Yeah, it doesn't. Since it didn't write my profile just yet, it couldn't load the data. But basically, once you have these details here, you should be able to see all of these details in an explore page, because this is where it pulls user profiles and comments. And the last thing that I wanted to show, I just don't know if I can, because it's not really working right now properly. But there is another way to easily interact with data that is stored on Ceramic, which is using GraphQL interface. So technically, when you build your app, you have these data models that you have defined. You will also have runtime representation of your data models, which will then allow you to write queries and interact with them. So yeah, since I can't get my node starting up properly now, I don't think that I can show that. But if you check our docs, or if you check these slides, that once again, I will make sure that we share them around, you will see the commands of how you can interact with GraphQL. So you just simply start a simple server, GraphQL server, and you then have simple interface where you can write GraphQL queries as follows. I can only show examples right now. So for example, you can write queries to read data. So for example, you can read data from simple profile model. Let's say get the first two records from this model and see the display names of the users. You can also write mutations and provide new data with actual variables. And so on. So it's just much easier and quicker way to test things on your end. Okay, so just to very quickly wrap up, again, I apologize that a lot of things didn't work today. I will double check what's happening and I will post a follow-up message on that. The last thing that I wanted to show is that we have quite a few notable community projects that hopefully will give developers some inspiration to build cool projects. I will not go into too much into detail on these, but these are just really great examples of how ComposeDB can be used to build really cool developer tooling and community platforms. And I also have a bunch of resources that hopefully will be useful for everyone. We have docs and all of that stuff, but the one that I wanted to mention at the very end is highernodes.io. This is something that developers can use to basically get a hosted Ceramic node, which might simplify your setup a little bit. This is built by our community members as well. So you can basically get a Ceramic node configured for you, for your project, and you don't have to do all of the setup yourself. Because otherwise you will have to run your own node, configure quite a few things. All of the details are in our documentation, but just wanted to highlight this just in case you want to consider this as an option. So yeah, I think that's all on my end. Once again, everything that I did show today, I'll make sure that it's shared around, that it's available, especially this example, because you can really use that as a basis for your project. So yeah, thanks so much. I'm really looking forward to see what developers can build.
Thank you so much, Justina. We have to end the call because we have another workshop coming up, but great to see everything that Ceramic is building and excited to see some projects coming up.
Yeah,
So see you guys soon. If you need any questions, just hit us up in Discord. Bye, guys.
Bye.